Once the foundations of quantitative inquiry are understood, once you recognize how variables reveal relationships and how measurement represents human experience with fairness, the next step is exploring the designs themselves. Quantitative designs vary not in sophistication, but in the type of structure they illuminate. Each design sees the world differently. Each one answers a different kind of question. And each one aligns with a specific type of tension inside your research problem. As we walk through the quantitative designs, think not about statistics or procedural steps, but about what each design allows you to see. Descriptive design sits at the doorway of quantitative inquiry. It sees the shape of what exists. Descriptive studies are chosen when the research problem reveals that the field does not yet know what is happening. The level of digital literacy across a district, the pattern of absenteeism in middle school, the distribution of engagement in an online course. The verbs reflect this role: describe, report, summarize. Variables are only measured here, not compared or related. Sampling aims for breadth so the picture represents the population accurately. Time is a simple snapshot or a series of snapshots if trends are needed. The data consists of numeric summaries, frequencies, percentages, means, standard deviations, and the analyses that match this design fall within descriptive statistics alone. The positionality of a descriptive researcher is rooted in humility, because descriptive work cannot claim relationships, differences, or causes. It simply clarifies what already exists. And because a dissertation must address a meaningful gap, deepen understanding, and speak to a tension within the field, descriptive design alone is almost never strong enough to serve as a standalone dissertation methodology. It does not illuminate mechanisms behind a phenomenon, reveal patterns of relationship, or surface differences that matter for practice. For this reason, descriptive design is typically used only as one component of a larger study, often paired with correlational or comparative approaches. It is chosen instead of other designs when the field needs clarity, not explanation. It serves as the map, not the journey. Correlational design sees how variables move together. It appears when the research problem reveals a gap in relationship rather than cause. When the field needs to understand whether two constructs rise together, decline together, or diverge. The verbs tell the story. Examine relationships and determine strength or weakness of relationships, association of variables, or prediction. Variables take on relational roles. One may have a statistically significant relationship, one may respond in a positive relationship, and covariates may help clarify the relationship. Sampling must be large enough to reveal stable patterns, and time may be cross-sectional or longitudinal depending on the question. The data structure expresses the strength, direction, and significance of relationships. Analyses that fit this design include correlation coefficients for simple relationships, linear or multiple regression when predictors influence an outcome, logistic regression when the outcome is categorical, and chi-square analysis when the relationship involves categorical variables, and the question concerns association rather than prediction. The positionality of the correlational researcher requires restraint and transparency. Correlation does not imply causation even when the numbers are compelling. A study examining the relationship between teacher self-efficacy and student engagement might reveal a strong connection, but the design honors the limits of what that connection means. Correlational design is chosen instead of causal-comparative work when the question is about association, not difference, and instead of quasi-experimental or experimental work when the researcher is not seeking influence or causality. Causal-comparative design sees naturally occurring differences between groups. It emerges when the research problem asks whether existing groups differ meaningfully on an outcome. These groups cannot be assigned by the researcher. They already exist. Students in traditional versus online learning, teachers with or without certification, schools implementing or not implementing a new policy. The verbs reflect this intention. Compare, examine differences, determine impact, though always with caution. Variables take shape around group membership as the independent variable and the measured outcome as the dependent variable. Sampling must attend to group sizes and potential sources of bias. Time is typically cross-sectional or retrospective. The data structure expresses group means and differences. Analyses that align with this design include independent samples t-tests for two groups, paired samples t-tests when the same group is measured twice, ANOVA for 3 or more groups, ANCOVA when covariates must be accounted for, and MANCOVA when multiple outcomes must be compared simultaneously, while controlling for covariates. MANCOVA extends the logic of MANOVA by adjusting for additional variables that could affect the comparison, allowing the researcher to examine several dependent variables at once while holding other influences constant. The researcher's positionality requires humility about causal inference. Because the groups were not randomly assigned, any differences found cannot be claimed as causes. Comparing achievement between online and traditional students reveals important patterns, but the design cannot assert that instructional modality caused those outcomes. Causal-comparative design is chosen instead of correlational work when the question is about differences rather than relationships, and instead of quasi-experimental work when the researcher cannot manipulate or assign conditions. Quasi-experimental design sees influence when control is limited. It appears when the research problem demands understanding the effect of an intervention or condition, but random assignment is not possible. Schools, districts, and social systems rarely allow random assignment for research, but they frequently introduce programs unevenly. Some classrooms adopt a strategy first, or some schools implement a policy sooner. These moments create opportunities to examine influence without violating ethical boundaries. The verbs reflect the aim: examine effects, determine influence, evaluate outcomes. Variables align with intervention logic. The independent variable is the program or condition, and the dependent variable is the outcome measured with validated instruments. Sampling follows intact classes, grade levels, or schools that naturally receive the intervention. Time unfolds through pre- and post-measurements or multiple checkpoints. The data structure shows change over time or adjusted comparisons. Analyses that fit quasi-experimental work include ANCOVA to adjust for baseline differences, repeated measures ANOVA to capture change within individuals or groups, and conceptual difference in differences approaches to compare trajectories. The researcher's positionality requires transparency. Without randomization, influence can be estimated but causality cannot be guaranteed. A study evaluating the impact of a literacy program implemented in some classrooms, but not others, is quasi-experimental, because the intervention was assigned by context, not by the researcher. This design is chosen instead of causal-comparative work when the intervention alters conditions over time, and instead of experimental work when the researcher cannot randomly assign participants. Quasi-experimental design is one of the most common and dissertation-friendly approaches in real-world social research. Experimental design sees causality supported by control. It is the strongest form of quantitative inference, but also the most ethically constrained in social and educational research. Cresswell reminds us that true experiments require random assignment to conditions, yet students are placed in classrooms based on schedules, legal requirements, and district structures. Teachers are assigned duties based on certification and employment decisions. Services cannot be withheld for research. Because of these ethical boundaries, experimental designs are rare in dissertation work unless the intervention is equitable and both conditions represent acceptable options. When an experiment is ethical and feasible, the verbs reflect its intent. Test the effect, determine causality, evaluate outcomes. Variables follow experimental logic. The independent variable is manipulated, the dependent variable is measured, and controls are used to isolate the effect. Measurement relies on validated instruments and standardized procedures. Sampling requires random assignment into conditions so differences in outcomes can be attributed to the intervention rather than pre-existing differences. The timing follows a clear sequence of intervention and outcome measurement. The data structure expresses controlled contrasts and effect sizes. Analyses that align with experiments include ANOVA and MANOVA for comparing outcomes across groups, factorial ANOVA for exploring interactions among conditions, and mixed model ANOVA for repeated measures. The researcher's positionality here involves ethical stewardship. The researcher is creating conditions, not simply observing them. This design is chosen instead of quasi-experimental work when true randomization is possible and ethical, and instead of causal-comparative work, when the researcher seeks causal answers rather than natural differences. Experimental design is used sparingly in dissertations because the context must allow it without compromising safety or equity. When seen together, these designs form a spectrum of structural insight. Descriptive designs clarify what exists. Correlational designs reveal how variables move together. Causal-comparative designs uncover differences between natural groups. Quasi-experimental designs illuminate influence when control is limited. Experimental designs determine causality when control is possible and ethical. The design does not emerge from preference. It emerges from the storyline of the research problem, the shape of the gap, the practical realities of the setting, and the type of truth the field needs. Quantitative research is often misunderstood as impersonal, but it is one of the most human commitments we make. Patterns matter because people live within them. When we reveal inequities with clarity, when we illuminate structures that shape experience, when we ground decisions in evidence rather than assumption, we honor the communities we serve. Quantitative designs help us see the world as it functions, not as we imagine it to be. With these designs understood, you are ready to move into the next stage, shaping the purpose statement and research questions that reflect the logic of your quantitative pathway. Your verbs will align with your design: describe, examine, compare, test, or determine, and your questions will take on the structure of the patterns you intend to study. The design becomes the blueprint, the purpose becomes the intention, and the research questions become the guide that leads your study forward with clarity and coherence.